Today we're going to look at the first half of this page of notes, and we'll be studying plate tectonics. Last week in the geology book that you read, it mentioned a little bit about plate tectonics. It told you that it was developed in 1912 by a German scientist named Alfred Wegener. And it was basically the idea that the continents used to be joined together, but that they have moved and drifted apart. So the Earth is actually broken up into these moving plates. We're going to study more about this concept over the next 2 weeks. As we do today's lesson, I will put up sections of your notes, and the new section that we're talking about will be in a red box, and then the words you need to write down will also be in red. Feel free to pause the video if you need more time to copy those blanks down and spell them correctly. So geologists believe that the geothermal energy or heat from the Earth's core has created cracks in the Earth's crust. In last week's book, it mentioned that geothermal activity is the heat that comes from inside the Earth. And that heat has actually caused the Earth's crust to be broken up into these cracks. You can see them in this map here. Those lines show where those cracks are. To understand how those cracks formed, think about water that is boiling. So we've got a stove underneath here, and we have water that's boiling. There's a heat source underneath, and that heat from underneath works its way slowly up through the material that's above it. And as it does that, it actually creates these patterns of heat waves where that heat actually travels in these currents, and we actually call those convection currents. The same thing is going on with the Earth. We have this incredibly hot core, and the heat from that core is working its way up through the outer core into the mantle and eventually up through to the crust. And that heat there's actually patterns to that heat, where in some places of the Earth, that heat is hotter, and in some places it's cooler as those convection currents, those waves of geothermal energy move through the Earth. Now, if you ever watched water boiling on a stove, you know that if you put the lid on that pot, it can eventually cause a problem. When you have heat that's building up and it's trapped with something covering the top of it, that heat energy as it builds up can actually get strong enough, in this case, to push the lid off of the pot. The same idea happens with the Earth. As that heat travels up, it has to go somewhere. It has to escape. And so eventually, it will actually create cracks to allow that heat to be released. So that's what's happened with our Earth. We have these cracks that have formed all around the Earth where the energy, that geothermal energy, has created these cracks in the surface of the Earth. Those cracks have divided the Earth up into really large pieces. We're talking like whole continents on a piece, massive, huge chunks of rock, and those are called tectonic plates. The word tectonic means related to something really big about the Earth, and plates because they're flat and they can move and shift just like a plate. So the Earth is kind of like an egg that has been boiled too long. The heat, as you hard boil that egg, got to be too much, and it caused the surface to crack. So you can see this is another satellite image of those tectonic plates. Now you can't really see them from space. It's not like they're drawn out clearly. Someone has added these lines on the map. But we know because of how we've studied those movements that where these plates are. And I do want to point out that those plates can be oceanic, meaning that they're made of just an ocean. Those plates can be what we call continental, which means they have like a continent or land on them. And then they can be ones that have a combination of both, where they've got oceanic parts to it, and they also have land continental parts to it. To help you visualize this better, let me go ahead and show you this video.
It happens because hot rock rises, heated by the Earth's core. Near the surface, the rock spreads in two directions and goes sideways. It begins to lose heat. Eventually, the much cooler rock sinks back down. Through this spreading process, the Earth's crust is very slowly dragged apart. And it's this that ultimately causes the continents to move.
So yes, you heard correctly. The continents themselves are actually moving. So all of these plates are moving away from each other as the heat causes them to shift. But they're huge. They're massive, massive, massive chunks of rock. So something that big cannot move very quickly. So in fact, on average, these tectonic plates only move about 2 inches in a year. That's right. Each plate would move on average about 2 inches in a year. They're moving, but it's incredibly slow. Now, wherever those plates touch one another, that border between 2 plates is called a plate boundary. And as we look at the plate boundaries on this map, you can see the names of some of these different types of plates. And we basically can take those plate boundaries where 2 plates are touching each other and divide them up into 3 basic types. So in some cases, the plates are pushing towards each other, as you can see right here between these 2 plates, they're coming together. In other cases, the plates are moving apart from one another, as we can see in this section where the plates are actually moving away from one another. And then sometimes the plates are sliding past one another like this. And we have a special name for each one of those types of movements at those plate boundaries. The first type of movement is called convergent, C-O-N-V-E-R-G-E-N-T. And a convergent plate boundary is where the plates are moving towards each other. They're coming together. The way I remember that is that convergent starts with C-O, so I remember it means come together. The first 2 letters of come are C-O, and the first 2 letters of convergent are C-O as well. Convergent plate boundaries, as I mentioned earlier, can be between 2 continental plates that are coming together. It can be 2 oceanic plates that are coming together, or it can be an oceanic plate and a continental plate coming together. And we'll study more specifically about those convergent plate boundaries on Wednesday's lesson. The second type of plate boundary is called divergent, D-I-V-E-R-G-E-N-T. And in a divergent plate boundary, the plates are pulling apart from one another. They're headed in the opposite directions from each other. I remember this because the first 3 letters of divergent are D-I-V, and the word divide, we know, is also to separate or put things apart into groups. So it's dividing apart, D-I-V, dividing apart. In divergent plate boundaries, as those plates move away from one another, wherever that gap is, the magma, the hot rock from underneath the earth, is going to come up in that little section, and it actually hardens to form new rock. So at divergent plate boundaries, as it mentioned in the video, the earth is actually growing. The earth's crust is actually getting bigger. It's only about 2 inches a year, but still, in those sections, the earth's crust is growing larger. The third type of plate boundary is called a transform plate boundary. And transform, it means they're not coming together, they're not separating away from each other, but they're simply sliding past one another. So they're kind of headed in opposite directions, but not the same of a divergent where they're exactly opposite, but more that they're sliding away from each other. So transform boundaries, T-R-A-N-S-F-O-R-M. I didn't have a super good way to come up with and remember this. The best I could come up with is that transform has an S in it, and the word slide has an S in it. Starts with an S, so that helps me to remember that they slide apart from one another. And wherever that sliding is taking place, it creates these cracks in the Earth's surface. And that is actually where earthquakes occur most often. So wherever the rocks are shifting as they move, sometimes they get stuck on each other and then they release, and it creates these earthquakes. That's all for today. Tune in tomorrow to learn more about the landform vocabulary at the bottom of your notes.